Unlike most programming languages, Java has been hyped and discussed in the press and has acquired an odd kind of image in some ways. Let me tell you just what Java really is. Java is a general-purpose programming language. In this regard, it's just like C, C++, Pascal, COBOL, Fortran, and any number of others. It's for writing programs, any kind of programs. Sure, it has some special purposes, such as writing embedded programs for cell phones, microwave ovens, and VCRs, but these are just specific applications of the same general-purpose language. It can be used to produce animated applets that dance around in a web browser, and we're going to be doing that in just a little while. But that's just another application of Java as a general-purpose language. Any program that can be written in any language can also be written in Java. Other general-purpose languages may be more or less suitable than Java for a specific application, but there's nothing inherently included as part of the Java to prevent you from writing any program you like. Java is a simple language. By this I mean the syntax of the language is very straightforward, and once you learn it, you can look at any Java statement and tell exactly what it's doing. Whenever you see a minus sign, for example, you know that one number is being subtracted from another. There are only a very few fundamental data types and very few Java keywords to manipulate them. Java programs are generally simple in the sense that they are written as a collection of small methods. A method is a named collection of executable commands. We'll be getting to that very soon. Java is scalable because it can be used for everything from embedded chips in portable devices to programs that run on mainframe computers and managed networks. This is really a function of it being a general-purpose language, but Java scales better than many other general-purpose languages. Java is an object-oriented programming language. It is so object-oriented that you can't help but write a Java program in terms of objects. If you have no prior programming experience, then you'll have no problem with this concept because you won't have any preconceived notions of what objects are. If you have some experience with another language, you'll find that things operate about the same in Java as they do in other object-oriented languages, but you must be very careful about some of the terminology. For example, the terms interface and property have special meanings in Java that can be entirely different from the meanings in other languages. I'll define every term as we come across it, but watch out for words that have different meanings because it can cause you a good deal of confusion. I know, I've been there. To make it sneakier, most of the words mean exactly the same for all programming languages, so you'll tend to assume they all mean the same things, but they don't. Java was based on C. That is, the syntax and general structure of C was used as the basis for the design of Java. The overall structure is different because of the objects, but almost every executable statement in Java could be included in a C program and would compile and run just fine. Now don't worry, you don't have to know C to take this course, but I needed to mention that for the people that already know C, because if you do, you're going to feel quite at home in certain places. If you have programming experience in C++, be prepared for a departure from what you know. Some of the words and syntax are going to be familiar, but be prepared for slightly different meanings. When Java first appeared on the scene, the hype was resounding everywhere. With all the rumors that were translated into facts by magazines and whatnot, it was hard to tell exactly what Java was. Now, the most absurd of these rumors have disappeared. Everybody pretty much knows that Java is not a kind of computer or a kind of terminal, but some other misconceptions still wander around. Java is not JavaScript. These are two entirely different languages. JavaScript is an extension of HTML and can be included in an HTML web page to do things like prompt for input from the user and display graphics and such. While it is true that Java can also do this, the process for doing so is quite different. Java is not an operating system. It does run inside a Java virtual machine, which is nothing more than a program that runs like any other program. We'll be talking about the virtual machine later. There was some talk at one time about an operating system that would run Java in its native mode, but nothing ever came of it. It's possible to do, but it's never been done. Java is not just for use on the internet. It does a lot of work on the internet, on both the server and client side, but these are really only special applications of a general-purpose programming language. Java is not a tiny language. Now, this may sound like it contradicts my earlier statement that Java is simple, but I don't mean for it to. Java comes with an enormous library of classes that you can include as part of your program. For just about anything you can think of that you'd like to do, Java has a class that will either do it or help you do it. These classes don't clutter up the language. You can still write your own classes to do things the way you'd like to have them done, but this huge library of classes is available as a standard part of Java if you decide you want to use it. In this lesson, I'm going to explain what you'll need to be able to write Java programs. Java comes in more than one form. Some are free for the download, and some you can buy in a box off the shelf. The decision is yours. It's my job to tell you what your options are so you can decide. There are two kinds of programmers in the world, those that prefer to work from the command line and those that prefer to work inside an IDE. The letters IDE stand for Integrated Development Environment, and there are several available. The command line version of Java and the IDE named NetBeans can be downloaded freely from Sun's Java website, and IDEs can be downloaded from a number of other websites. Let me run through the list of things that are available, then I'll tell you how to find the URLs so you can locate everything. I'll start by listing the IDEs. No two IDEs are alike. Each one has its own approach to software development. If you decide you want to use an IDE, you're going to need to look around to find one that fits with what you would like to do and the way you like to do things. The Sun1 Studio IDE is an extension of the NetBeans development system that's freely available from Sun's Java website. Like most of the IDEs, you can download an evaluation copy. Possibly the most popular of the commercial IDEs is Borland's JBuilder. It's also possible to download an evaluation copy that you can use to find out whether or not you like it. The JRun IDE from Macromedia has a version for Windows and a version for the Macintosh. In fact, Java is becoming quite popular on the Mac, and you can choose from more than one IDE. MetroWorks produces an IDE for Linux called CodeWarrior. It can also be used to program in languages other than Java. JDeveloper from Oracle can be used in any Java development project, but it has special features that make it easy to work with the Oracle database. JCreator is probably the simplest of the IDEs. It was designed as a text editor that includes special commands to compile and run Java program. It has both a free version and a commercial version. If you're going to be using an IDE to develop Java for the Internet, you probably should take a look at WebSphere from IBM because that's what it was designed to do. The website has an online demo to show you how it works. Apple has its own Java development system, and Apple being what Apple is, the development system is in the form of an IDE. The problem with listing a bunch of URLs is that they're bound to change. To prevent this from happening, I list all of the URLs on a web page so I can keep it updated. I update it whenever I find something has changed and try to go and check all the links at least once a month to make sure they all work. This doesn't mean that I guarantee every link every time because nobody seems to check with me before they change something. Anyway, the link you see on your screen now is the page where I keep all the current Java links. These include links to the Sun download page, all the IDEs that I know about, and some other handy things, such as text editors for those who like to work from the command line. If you decide to use an IDE, you are pretty much on your own, but they all come with pretty good documentation. If I were to try to teach all of the IDEs, there would be no time to show you anything else. I teach this course using a text editor and the command line compiler because that is the simplest form of presentation on the screen. In the next lesson, I'll give you some information on getting set up to write and compile programs working from the command line. Before getting into the details of installing the command line form of Java, let me define a few terms. It seems that acronyms are a part of life when it comes to computing, and Java is no exception. In fact, some of the acronyms can be confusing and can certainly cause you problems if you get them mixed up, especially during installation and setup. The acronym SDK stands for Software Development Kit, and the acronym JDK stands for Java Development Kit. The two terms mean the same thing and are used interchangeably. Throughout Java, you'll find both terms used. The term SDK is the oldest, and the trend seems to be toward using JDK, but the transition is inconsistent, and both terms are used in both the new and old documentation. The SE stands for Standard Edition. The J stands for Java, and the J2 stands for Java 2. Now, these two terms are, in fact, used to stand for the SDK and the JDK. These acronyms are not used as often as the first two, but they do come into play during installation. When you want to download Java from the Sun website, you'll find it listed as the J2SE. The name Java 2 is a bit of an oddity. Java 2 is the generic term for any version of Java version 1.2 or later. All versions of Java up through 1.1 are just called Java, but all versions beginning with 1.2 are called Java 2. It is true that going from 1.1 to 1.2 was a major revision, but I think they could have done a better job of naming things. We've moved well beyond version 1.2 now, so you can just consider all versions of Java to be Java 2. The RE stands for Runtime Edition. The Runtime Edition is the collection of files that you need to be able to run Java programs. Now, this collection does not include the compiler or anything else you'll need to write programs. It only contains what you need to run programs. The complete J2RE is included inside the J2SE, so you don't need to download them separately. The letters ME stand for Micro Edition. The J2ME is for writing embedded systems for such things as automobile engines and answering machines. We won't be using the J2ME in this course. The letters EE stand for Enterprise Edition. It's an add-on collection of classes that can be used to extend the capabilities of the Standard Edition. It does not contain the SDK. It is for use with the J2SE. We won't be using the J2EE in this course. That's not all. If you look around the Sun website, you'll discover a number of other sets of Java classes. For example, JAXP can be used to manipulate XML documents. JAIN can be used in conjunction with the J2SE to develop telecommunications software. And the JMI is the Java Metadata Interface. All you need for everything in this course is inside the J2SE. And the next lesson is about downloading that and getting it ready to develop software. If you want to write Java programs using a text editor and the command line compiler, this lesson is going to tell you what you need to do to get ready. There are only three things to consider. You need to download the compiler, decide on a text editor, and set the path variable. Once you've completed these three steps, you're ready to start writing and compiling Java programs. Downloading and installing the Java compiler is the simplest of the three steps. You go to this website and select the version you wish to install and start downloading the file. You'll find several versions of Java available for Solaris, Linux, and Windows. I can't tell you which version to download because new ones keep appearing all the time, but you should be able to select one that'll work for you using the terminology from the previous lesson. If you use a modem to connect to the internet, you should be aware that the downloads are large, multiple megabytes, and the later the version, the larger the download. One of the options you'll have presented to you is to download the NetBeans version of Java. NetBeans is an IDE, so if you're in the process of evaluating IDEs, you probably want to try this one. You can only download one version or the other. It's never a good idea to mix an IDE version of Java with a non-IDE version on the same machine. You wind up with a system that's mixed up and may or may not work, and you really can't trust it. Of course, you can pick one and try it, then uninstall it, and try another. There's no problem in loading several different versions of the command line compiler onto the same machine. They don't interfere with each other in any way. Once you have downloaded the file from Sun, you'll need to execute it, and it will guide you through the installation process, which is really nothing more than selecting some options and an installation directory. The default selections are fine. The next thing you'll want to do is decide on your text editor. You can download a new editor if you like, or you can use one of the ones you already have. Some folks like to use a word processor, but if you do, make sure you always save the Java files as plain ASCII text. The point is, which editor you use doesn't make any difference as long as you're able to create and modify ASCII text files. The traditional editor that comes with DOS is called Edit. It's already installed, and you can run it by simply entering the word edit from the command line. It's a bit of a rudimentary editor and takes a bit of learning, so if you're going to be learning a new text editor, I would suggest spending your time learning a different one. Another editor that comes with DOS and Windows is called Notepad. It's a fairly simple editor, but lots of people seem to like it. It does have one strange quirk. Whenever you save a file to a new name, you must put quotes around the name. If you don't, the editor will change the name to something else. It'll trim off the end of the name and stick something else on there. The Notetab editor is free for the download. Many people like this editor very much. That seems especially true of those that have used Notepad or Edit for any length of time. It does have some features that make it easier to compile and run Java programs. TextPad is another editor that many people have recommended. It also has features for compiling and running programs, and some prefer it to Notepad. You can find links to these editors through this website. Also, this website includes links to other editors and tools that you may find useful. I can't list the current state of everything here because it all keeps changing, so if you're exploring for a new editor, go take a look at the current list at this website. The third and final step is to insert the name of the directory into those included in the path environment variable. Now, if you're unfamiliar with path, you may want to go and find some documentation that fits with your system to find out what the path environment variable is and how to set it. Simply put, the path environment variable contains a list of names of directories. Whenever you enter a command from the command line, the system will search through the directories for a program by that name, and if it finds one, it runs the program. You must have the path set to the directory containing the Java compiler and the other Java programs, as well as your text editor. To see how it's currently set on your system, just open a DOS window and enter the word path. The current path setting will be listed. Each of the directories in the list will be searched for any command you enter. Notice in this example that the last directory in the list is the one that was added, and it's the one containing the Java compiler for Java version 1.4.2. The path variable contents can be edited in the System Properties window. The window shown here lists the environment variables on a Windows XP system, but other versions of Windows, since 95 and 98, all work basically the same way. This course starts from the very beginning and assumes you have no prior programming experience, but assumes you have some basic computer skills and can download stuff and install it and run programs. This is a practical course. That means that as much as possible it's taught with examples. The examples are simple and hopefully easy to understand. They're designed to demonstrate just one or two things. Now, early on, I have to do a bit of explaining before we get into an example, but as things go along, more and more of the course is taught by pure example. I hope you can bear with me through some of the early lecturing. I keep it to a minimum and just cover the stuff that you're actually going to use. Source code is provided for every example program shown in every lesson. Once you have your version of the Java compiler installed, you should be able to compile and run every one of them. And you should, so you can get a feel for how this thing actually works. To prevent confusion, care was taken that no two programs in the entire course have the same name. Also, they're organized by chapters, so you'll be able to quickly find the one you want. Everything starts by showing the fundamental shape of a Java program. It displays a line of text. The first program displays it as a response from the command line, and the second displays it in a window. The text in a window stuff deals with font selection, color selection, and measuring the font. Then we start looking at the small stuff. We look into character strings and arrays. And oh, if you haven't worked with Java or C before, get ready for some really strange arithmetic operators. Anyway, we take a quick whirl around the basics. Then we go back up a few paces and look at the overall structure of a Java program. All that object-oriented stuff is explained in very simple terms. Once you see how something works, I give you the strange object-oriented word for it, so you have something to pin the word on when you get it. Then we dive right into graphics, so you can get a good idea of how the little stuff and the big stuff all work together to make a program. We'll be drawing pictures in the windows, and we'll be loading image files and displaying them in windows. Now that we know how to draw, the next logical thing is to make it move. Java animation is rather straightforward, but there are a couple of sneaky tricks you need to know about before you can make it work. I'll be showing you several examples, each one of them with a slightly different slant. Then we shift gears and go into applets. Using all the stuff we learned previously, we experiment with displaying text and graphics in a window inside your web browser. Then we translate the animation trick into the applets, and you're ready to go live on the internet with Java. Back to the applications again, this time using the mouse to drag stuff around a window. Next come the push buttons and the other forms of user input. There are all kinds of gadgets in Java that you can use to get a response from a user. All of these gadgets and whatnot need to be controlled. So we take a good close look inside at the software that's used to construct window layouts with buttons and text entry windows and so on. Not only do we have the top-level window with user input devices, we create pop-up dialogues of various kinds that can provide a wide variety to the way that your user interfaces with your program. At the end, you'll be able to fill a window with just about anything you like, pull-downs and pop-ups, including a menu bar across the top of your windows. By the time you finish this course, you will be able to write just about any program you would like in Java. If there's something you don't know, you'll have a good idea of how to go about finding out about it. Java is huge, but this course was carefully devised to cover the fundamentals of the operative parts.